Today we got quadratic equations and functions. This should be a review today with the exception of maybe some of the discriminant stuff. So depending upon who you had for algebra, you may or may not have seen and utilized the discriminant, but it's a pretty easy piece. So your job right now, get that down and then write out that quadratic formula. Hopefully you remember it. Okay, here we go. Quadratic formula, volunteer. Yes, Hannah?
Negative b plus or minus square root of 2a minus 4ac, right?
Opposite of b plus or minus square root of b squared minus 4ac all over 2a. I know you love the song. Pop goes. It reminds me of Elf now. You know, when he like has to freak out. Opposite of b plus or minus square root of b squared minus 4ac all over 2a. Eh? There we got it. Now remember, we're solving for x, right? Okay, so just to make sure that we're clear, you've learned multiple methods for solving equations, quadratic equations. We've talked about solving using graphing. We've talked about solving using your calculator and matrices. We've talked about solving using factoring, solving using difference of two square, or excuse me, perfect square trinomial, or perfect square trinomials, and then using the quadratic formulas today. They all do the same thing. The benefit of the quadratic formula, it works for every quadratic. So if there's factoring is very quick a lot of the times. However, not all quadratics can be factored. So let's go ahead and try some of these. Number 1 off your assignment. Okay, using the quadratic formula, we're going to solve. Now, I want you to use the quadratic formula here. Some of you would recognize, hey, I could factor that, and it would save you time. I mean, you should be able to hopefully get to the point where you know the answer about now. Okay, by factoring. What does it factor to? Oh, that's not good. X plus 1, x minus 3. That means our answers are -1 and +3. However, your job right now is to apply the quadratic formula. And in order to do the quadratic formula, so again, I'll write it up here. I know it's been a while since you've used it. In order to utilize the quadratic formula, you need to know a, b, and c. So when I'm looking at this, a has to be, when it's in standard form, there's a, there's b, and there's c. And notice I circle that negative with it. So when I'm putting this in, saying x equals the opposite of b, well, if b is negative, the opposite of it is positive, plus or minus square root of b squared. -2 squared is 4, minus 4 times a times c. Now I really focus in on this back piece because a lot of the times when students make mistakes, here's where their mistake gets made. Okay, so let me zoom in on that. That is a -1, or excuse me, a -4 times 1 times -3. -4 times 1 times -3, that's a negative and a negative. Either A or C are negative. If either A or C are negative, then this is going to make a positive value right here. I always circle it and write in what that is. That gives me a positive 12. Then we have all over 2 times 1. That way, when I simplify, it's 2 plus minus 4 plus 12 there, over 2. It's equal to 2 plus minus root 16 over 2, which gives me 2 plus minus 4 over 2. And at this point, once I'm down, I've simplified that radical as much as I can, I now have two answers. I have 2 plus 4 over 2, which is 6 over 2, or 3, and 2 minus 4 over 2, or negative 2 over 2, which is negative 1. Once again, we knew that going in because we could factor that. So my solutions, x equals the set containing negative 1 and 3. Cool.
Can you simplify that more, like 2 divided by 2 and 4 over 2? Because I think that would still give you the same answers.
It would. Yeah, if you divided both of those by 2. Yeah. It's just, I find it easier to add and then divide. But if you wanted to, you could. Yeah. Other questions? Okay. Whenever we try number 7, or number 4, excuse me, number 4. I just wanted to say 7. Number 4 on your own. Okay, there's the setup. Make sure you have that accurate, right? It's the opposite of b, so since b is negative, that becomes positive. Remember, anytime you square something, whether it's negative or positive, it becomes positive. So b squared is always going to be a positive number there. And then this piece right here, once again, I like to focus on that. I even circle it and write it right up here. This is going to give me a negative 84, I believe. 21 times 4, yeah. Negative 84 there. Okay, so I get 12 plus minus root 144 minus 84 all over 14. (144 minus 84 gives me 60. Is this going to be rational or irrational? Irrational. That radical isn't going to simplify completely. It'll simplify a bit. All right, you get 12 plus minus. Yeah, good. 4 times 15, which breaks down to 2 root 15 over 14. So we can simplify anything outside radical symbols. So let me write this a little bigger for you and separate it a bit. 12 plus minus 2 root 15 all over 14. If things are outside of the radicals, then you can simplify them. I can't simplify, I can't deal with a 14 and a 15. There's nothing that goes into them anyway, but even if there was, I couldn't simplify because this one's in a radical and this one's not. But I can simplify here and there. Okay, so 12 and 14, what goes into both those? Well, it becomes a 2, and 2 goes into that. So 2 goes into this 6. 2 goes into this once, so it just becomes a 1. So 1 root 15, you don't need to show the 1, but there it is. And then 2 goes into 14 7 times. It has to go into all 3 parts if you're going to simplify that way. All right? So my answer is this. I can't simplify anymore. Remember, that's made up of 2 different solutions still. Right? That's how we report our answer. The actual solutions here, 6 plus root 15 over 7 and 6 minus root 15 over 7. Those are the actual two solutions that are reported there. So these would be your x-intercepts or your roots or your zeros. Yeah?
You do not want us to calculate that, right?
Not unless it tells you to round to the nearest tenth. I don't know what does your paper say to round?
No, it's not.
Okay, then leave it in radical form now. At least for these. I'll tell you, once we start our assignment, I'll tell you what I want, what answer I wanted in. Yeah?
When we answered, do you want us to just do the one on the left that he circled or the one on the right?
Right now, I would put, you keep it in this form. Yep. Once we start our assignment, I'll tell you guys if I want it in radical or non-radical. I want you to round it or not. Okay? All right. Any questions there? I don't think we have to spend much more time on it with the exception on quadratic formula. I need you to tell your neighbor what has to be done to that problem before you can start it. Okay, what has to be done to this one? Yeah.
You have to subtract by the square root each side, and then you have to divide that by negative.
Okay, so you have to get it in standard form, right?
And
So I would suggest moving these two pieces over, but you could subtract that and then factor out a -1. Flip the signs. So if I'm doing that, it's 5x squared minus 8x plus 6 equals 0. Okay? So once you get it into standard form, then it makes it a bit easier to deal with. All right. In fact, let's go ahead and finish this one up. This one's going to give us a nice, fun, different answer. It'll be a hoot. Woohoo! All right. First, how many got to this point here? Okay, 2i root 14, right? It's -56. We pull out that negative with the I. We factor root 4 by root 14. Root 4 is 2, so 2i root 14. Okay, and then we can simplify by 2. 2 goes into all three of these things. Now, can we take it out of the 14? No, because 14's inside there. So I take 2 out here, that becomes 4. Take 2 out here, it becomes 5. Take 2 out here, it becomes 1. So we end up with x equals that is our solution. I think it's cool.
it's a really
Yeah. All right. Any questions? Okay. Yeah, go ahead.
So when we're writing the solutions, do you want it in plus minus, or do you want plus and minus?
I want it in the compact form. Yeah. Okay. Other questions? All right. So on today's assignment, you're going to leave everything in either fraction or radical form. Okay. Now, just so that we understand that picture, when you get imaginary solutions, tell your neighbor what that looks like on a picture.
Oh, you have the
All right, here we go. Which one of those pictures does it look like? A, B, or C?
no intercept.
Imaginary solutions.
Supposed to be no intercept.
Okay, we used to call the imaginary prior. Back about a week ago, when you guys saw this negative, you said, hey, that's a no solution, meaning no x-intercepts. Okay? Now, this happens when you have one real solution, right? When you, maybe your answer is something like x minus 2 quantity squared equals 0. And you say, well, the answer then is x equals 2. That means it hits it in one spot. Okay? This would be something like x minus 5 and x plus 5, maybe, or 4, maybe we use so that we don't think that it has to be the same thing. But one answer is 5 and one answer is -4. So they hit at 5 and -4. If it's negative, then it opens downward. This is an example of an imaginary solution. Maybe you get 4i root 2. Okay? That's your imaginary solutions. Okay. Any questions there? Okay. So just so you're clear, we have ways to figure that out. All right? If you think back to this problem, there was a point in time. Well, I recognized it early on because I looked at this and I said, well, this right here is going to pose a different type of problem for you. What tells you that this is going to give you a different type of problem? Yeah?
5 and 6 are both positive, but there's one negative, so that's probably.
Yeah, this is going to be, the back part here is going to be negative, and it's a bigger negative than this. 5 and 6 are both positive, okay? This amount in here, this thing inside here, this whole b squared, if you think of our quadratic formula, when we're going through it, and x is equal to opposite of b plus or minus square root of b squared minus 4ac, that piece in there, that piece inside there, if we just focus in on the b squared minus the 4ac, that chunk right there, if you calculate that ahead of time, we would have found out that that answer is negative 56. That tells you you're taking the root of a negative number. Anytime you have the root of a negative number, it's no solution. Anytime you have the root of a positive number, like we had on our previous problems, how many solutions did we have? 2. Okay, so when do you get, if b squared minus 4ac is negative, that's no real solutions. The solutions are imaginaries. If b squared minus 4ac is positive, then it's 2 real solutions. When do we get 1 real solution? Talk with your neighbors. When could you get 1 real solution?
When the plus, when the b, negative b plus, all that root stuff is equal to the negative b minus all that good stuff.
Okay, volunteer. When do we get 1 real solution? Tyler.
When the x intercept is the vertex.
Okay, so how do I know from this? Without a picture, how do I get 1 real solution? Yep.
If the b squared plus or minus 2c squared is 0, then it would be 1 solution.
Good. If b squared minus 4ac equals 0, then it's 1 real solution. Okay, now think about what that means. If this equals 0, really this whole back piece drops off. And I am now just left with, there's no plus minus anymore. It disappears. When we say plus minus 0, it doesn't change anything. So if that would have happened here, we would have had 8 over 10. Our solution would have been 4/5, 8 over 10. 1 solution. Okay? So if the back part is 0. So really, if you're summarizing your thoughts here, and that's really what this is saying, if b squared minus 4ac equals 0, it's 1 real solution. If b squared minus 4ac is greater than 0, or if it's positive, there are 2 real solutions. If b squared minus 4ac is negative, then there's no real solutions, or there are 2 complex solutions. They're imaginary. This is called the discriminant. Now please note that the b squared minus 4ac is called the discriminant. Only the b squared minus 4ac. Not the square root. Okay, it's just the thing inside the radical. We call that the discriminant. And it helps us to determine how many solutions there are. So if you calculate the discriminant, you should be able to quickly figure out how many solutions that equation will have. That's on page 242.
Oh, you're just hiding that. That was the same page.
What's that?
Oh, when you were showing us the 2 x intercepts 1 x intercept and no intercept, then you were just hiding the other part.
Yeah.
You didn't have a separate page.
That's true, yeah. It's called magic.
So,
Yeah, without being magical. I don't want to use my
That's
wizard
true
skills
magic.
too often. All right.
true
There you go. Evaluate the discriminant, and then tell how many solutions there are, and if they are real or complex. $256, I think. Hoping you guys are checking my work there.
Checking your work? Yeah. Yep. Yeah, you're good.
Okay, so I'm just doing my b squared minus 4ac. Hi.
Is it 64 minus 8?
I was
like
gonna say it's 56.
Wait.
64 minus 8 is 56.
Yeah.
Thank you.
Okay, I was figuring the 64 was wrong.
That wasn't the one I was concerned about, but I guess I should have been. Unbelievable.
The other two are right.
All right. So, evaluating the discriminant means finding this. You've now evaluated it. Okay? Tell how many solutions. Well, how many solutions? There are two, and whether they're real or complex. Well, these are two real because the discriminant's positive. How many solutions here?
One.
One. And it's real. Now, could I ever have one complex?
No.
No. I can't have one complex, right? I could have, how many do I have here?
2.
Well, I have 0 real, but I have 2 complex. Okay, so I have no real here, but 2 complex. That's pretty complex, dude.
That is too complex.
Not too complex. I mean, you guys can do it. Yeah.
How do you know what the complex solutions are?
How do you know what the complex? You'd actually have to do the quadratic formula.
Well, like how do you know how many there are?
I know there are 2. I know my solutions are complex because the discriminant's negative. So if I was to continue this quadratic formula here, that would mean I'd have positive 8 plus minus the square root of negative 192. And so all over 16. And so that tells me right here I'm going to have an I, which means those are complex. So that's why we just worry about that piece. Good question. Other questions? Lucy? No? Just stretching? Okay. I do that sometimes. Okay. Very good. Okay, your assignment then. Let's take a look at your worksheet that you picked up on the way in. You're going to turn it over and take a look at the mixed side. How many are we doing? Well, oh, since some of you want to do all of them, we will go and
No. I have a light.
who does?
We can just make the people who want to do all of it do all of it.
All right, so what we'll do is we'll cross out that one and that one. And we'll skip number 1. Okay, you can't see that, but skip number 1. Skip 2 probs, that's short for problems, from each section. So that means skip 2 from here, you choose which 2. Skip 2 from here, you choose which 2. And skip 2 from here, you choose which 2.
Yay.
Now please understand what it's asking on these. So read through the instructions. right now. Go ahead and read through each set. Okay, so real quick, I heard some of you actually reading this one. Without graphing, tell me how many x-intercepts each have. Are you doing the quadratic formula on this?
No.
You could. It's probably more work than needed. What do you need to figure out?
The discriminant.
The discriminant. It doesn't even tell you to find the discriminant. But you're telling how many x-intercepts, and that's utilizing the discriminant. Right? Just b squared minus 4ac. This one right here. Evaluate the discriminant. Tell how many solutions. And if they're real or complex. Do you use the whole quadratic formula?
No.
No. Once again, you're doing what we just did on this page. Okay? The only ones you really need to use the quadratic formula on are the ones that say solve each by using the quadratic formula. Okay?
I would guess that.
Now it's up to you which ones you do. Remember, you can skip 2. Okay, that gives you 9 problems here that you have to use the quadratic formula on. Okay? Any questions? In fact, I'm going to let you skip 4 from this section just because I'm feeling generous. Okay, well, don't skip 4. Okay, skip 4 from this section if you want. For those of you that can't change your instructions there, then okay. Just because I don't know that you need that much work on the quadratic formula. Okay, so skip 4 from there, skip 2 here, and skip 2 there, and if you want, you can do them for extra credit. All right. Very good. Go at it.